guys, and we are at chapter 9 activities, and we are about to answer all these activities in this video. So the first activity is activity TCP and UDP characteristic. And we all know that chapter 9 is also known as the transport layers. So let's drag each characteristic to its TCP or UDP delivery method. So we all know some characteristic of TCP are some guaranteed, and the UDP is fast and other things. So let's try. Then connectionless. Connectionless would go to UDP because TCP, we all know that TCP are always or somewhat guaranteed and always acknowledge a message. Then less overhead, it would be still UDP. Then fast transmission requirements, it would be UDP because UDP is for live streaming, and in order to have some live stream or some other stuff, you need fast transmission requirements and not slow, because slow can either make a good preference or other stuff. Then sequence message segment, we will drag it to TCP because TCP returns after TCP sends some parts from a device. The device would acknowledge that message and return some message to TCP. Then again, then the host would send another one. It is somewhat segmented, so it would be TCP. Then no acknowledgement of recipient, it will be UDP because UDP needs to be fast, so it should not go or should not have a acknowledgement of the recipient. So the no order delivery, still it would be UDP because UDP has no order delivery. It still just goes from host and goes all the way from the recipient. Then this 4 will be in TCP because TCP is already guaranteed delivery. Even there's a connection loss or somewhat other things like that, TCP is much guaranteed than UDP. Then flow control, because it's somewhat flow control of it is the message are segmented. Then session establishment, the recipients acknowledge when it receives the package. Then order delivery, as you can see, it have segments, it's flow control, so it will be an order delivery. So let's check. As you can see, all the answers are correct. Then let's proceed to another one. This is the second activity of the chapter 9 transport layer. The activity is called the part 1 TCP connection and termination process. Then we are here to drag each descriptor to its appropriate place in the image to illustrate the three-way handshake of a TCP establishment session. So the first we all know that the first step is the initiating client request a client server communication session with the server. So it would be a sync. Then the step 2 is the server acknowledge the client to server communication session and request a server to client communication session. So it will be acknowledge and sync. Then step 3 is the initiating client acknowledge the server to client communication session. So it will acknowledge. So you can see all our answers are correct, and somewhat we are gonna go to the part 2 or the figure 2. Part 2 TCP connection and termination process. Drag each descriptor to its appropriate place in the image to illustrate the 4-step process of a TCP termination session. So the first step is when a client has no more data to send in the stream, it sends a segment with the fin flag set. So it would drag a fin flag set. Then the step 2 is the server sends an act to acknowledge the recipient of the pin to terminate the session. Then this would be act again. Then another fin. The third is the server sends a fin to the client to terminate the server to client session. Then the pattern here is fin act. Then the step 4 or the part 4 would be the client responds with an act to acknowledge the fin from the server. In order to end it, you should acknowledge. Then let's check. As you can see, all the answers are also correct, and we've answered the TCP connection termination process and the part of it. And let's go to another one. And somewhat this is the last activity of chapter 9, the transport layer, and this activity is the TCP, UDP, or both. It somewhat drags the application layer protocol to its transport layer delivery method, TCP, UDP, or both. And somewhat we need to discuss what is TCP and UDP first. So let's try to answer it. TCP. TCP is somewhat, it handles all tasks associated with dividing the data system or data stream into segments, providing it some reliability, controlling data flow, and the ordering of segment. TCP frees the application from having to manage any of these tasks. Application can send the data stream to the transport layer and use the service of TCP. So there are some applications that can do that, and in that application it would be a TCP. Then first of all, that first application would be HTTP, or the protocol is HTTP, then the telnet, of course, then the FTP, and let's not forget the SMTP. This four protocols can data stream into segments that can provide reliability, control data flow, and reordering of segments. Then let's try to UDP. We all know that UDP have three types. The live video and multimedia application, it is somewhat just like in streaming, or when you are playing a game and you want it to share in a Twitch TV, YouTube, Facebook, and Instagram, and other stuff where you can live stream. It is somewhat in use. So in live streaming, somewhat they can tolerate a data loss and still have some delay, but still it can be viewable and you can watch it. Then it would be, as you can see, these two VoIP and the IPTV, because somewhat they are both in some streaming, they are both used in some streaming, some live videos and other stuff. Then the second type of UDP is application that handle reliability themselves. Then it is somewhat TFTP and DNS, I think, for that, or TFTP or SNMP. And let's TFTP, because TFTP can somewhat do and rely on themselves, because they can do the error detection, the acknowledgement, the sending of the users, and other stuff. Then the third application, or the last application, would be, or types, I mean, not application, would be a simple request or reply application. Then that would be a DHCP. Then the both is in both, that will be in TCP and UDP, are SNMP and DNS. Why DNS? Because DNS is somewhat will use DNS if DNS request or DNS response is DNS can be UDP, but you can use DNS if DNS request or DNS response is more than 512 bytes, such as when a DNS response include a larger number of resolution or requests. Then SYN SNP is in both because under some situations, network administrator may want to configure SNMP as an or to convert SNMP to a TCP. Then that's all. Let's check. As you can see, all the answers are correct because I've studied something about all of this, and that's end of this video. Thank you very much.